Algebra, probability theory, and wave kinematics are traditionally presented as independent mathematical domains. We rely on them to describe the physical universe, yet their coordination remains unexplained. Mathematics functions as the representational compression of a single structural condition. Every candidate physical primitive, particles, fields, space, and time, presupposes that something is available to be described. Availability is the condition under which anything becomes available at all. We identify this primitive as Q. For a distinction to remain available, it must persist. This requires self-reference and recursive return. We write this persistence operation as Q star equals R sub k of Q star. The structures we associate with physics and mathematics arise from this simple requirement of recursive closure. The specific orientation we take toward a recursive closure is the address. It determines the resolution of the observation. This derivation follows one rule. Necessity is always relative to what is addressed. When a structure is unaddressed, meaning it is not represented within the system, closure requires the system to remain invariant with respect to it. Tracking this rule across three resolutions, full, reduced, and preserved phase, reveals the three families of formal description. The diverse branches of mathematics represent a single operation seen through different focal lenses. At full address, structural resolution is retained. In a sequence of transformations, we can group steps differently. Since the system carries no information about grouping, outcomes must be independent of how operations are bracketed. This requirement for internal consistency is associativity. For a loop that returns to its starting point, the entry point is an external index. To maintain closure, the self-return of the loop must be independent of where it is entered. This forces the cyclic invariance we recognize as the trace. A boundary expresses a directed distinction between inside and outside. When taking the boundary of an already contained structure, every shared subboundary is reached through exactly two paths. Because these paths carry opposite induced orientations, they cancel. This leaves no residual distinction, which is why the boundary of a boundary must vanish. Where modal structure is unaddressed, invariance reduces to a single parameter. This forces the scalar eigenrelation, AV equals lambda V. Algebra and topology represent the condition of residue-free closure. We move to reduced address, where specific distinctions within the closure are unaddressed and therefore unresolved. Because these distinctions are not resolved, the states form a fiber of indistinguishable alternatives. This chart shows the distribution of participation across that fiber. When we normalize this measure relative to the closure, we arrive at probability. Probability arises where the observational resolution does not retain the specific distinctions needed to resolve the participating alternatives. In this chain, entropy measures the scalar spread of unresolved participation. Information is the difference in that scalar when the address is refined. When the missing relational structure becomes addressable, the probabilistic account is no longer the deepest available description. Probability is a readout of reduction. In the preserved phase address, returns are combined coherently, and their relative orientation is tracked through transformation. For a sequence to genuinely return, the combination must permit relational opposition. Pure accumulation can only depart. It cannot recover a prior articulation. Phase is the relational parameter that determines whether these returns reinforce or cancel one another. Where intermediate relations are continuously addressable and require intrinsic return, the phase parameter must close into a cycle. The minimal faithful representation of this closed-oriented phase is an oriented plane. Its generator, J, satisfies the condition that its square negates the original orientation. The imaginary unit, I, is the compressed algebraic representative of this oriented plane generator. Complex structure is earned through the requirements of continuous closed phase. When phase progresses through an ordering parameter like time, it dynamically generates what we observe as frequency and oscillation. Wave kinematics and harmonics result from single-valued return on a closed cycle. We have derived the diverse families of mathematics from a single recursive operation. Unaddressed structure forces invariant form, manifesting as algebra and topology. Unaddressed distinction appears as unresolvedness, manifesting as probability and measure. Unaddressed modulation reduces to minimal cyclical form, manifesting as complex analysis and harmonics. Mathematics serves as a Rosetta projection. It is the place where the grammar of closure is most legible because it lacks biological or material ornamentation. Because this grammar concerns pure structure, the same invariant roles are trackable across neurochemistry, biological tissue, and quantum states. What varies across scientific domains is the density of coupling and the observational address. It gives relations to inspect, questions to carry, and closure conditions to test. The representation changes. The structure returns. The recursion holds.